Hey everybody, this is Brian. Welcome to the first Flutter tutorial. You'll note at the time of this recording, Flutter is still in alpha and is an open source project. Now, version 2 is coming very soon, and I'm going to try to adhere to version 2 so that going forward this tutorial set remains relevant. So first off, what is Flutter? Well, it is a mobile app SDK that helps you build pretty beautiful applications very quickly. There is an actual really nice fact in here that you should read and get accustomed to is, what is it? Who uses it? What's it for? Answer some general questions right now. It's really designed to make mobile programming not suck. If you've ever tried making a mobile program cross-platform, you've had just a major headache. Who's it for? Developers of all walks of life, but mainly people targeting mobile development. Flutter is built upon a language called Dart, which is a new language, which I believe, somebody correct me if I'm wrong, was actually developed by Google, or at least had a lot of Google backing. Google depends on Dart to make very large apps. You can see that there. So this has a few distinctions from other mobile frameworks. You can build cross-platform, and this Hacker Noon article, I'm not going to steal all their thunder, but what's really differently is you have, OEM SDKs where you have native code that runs on a specific platform. For example, an Android app will not run on iOS, iOS will not run on Android. You have web views, which are kind of like I want to say a hybrid, where you have like Cordova, Ionic, et cetera, where you have a JavaScript application that communicates with a bridge, which actually communicates with the hardware. Then you have what are called reactive views, where you have JavaScript, which communicates with a bridge, same thing, talks to the hardware. What's different about Flutter is the Flutter SDK is really the only SDK out there that doesn't really use a JavaScript bridge. And it's actually very quick, very easy. I want to say very expressive, and I want to say easy to learn. We're going to find out. I'm currently building my own Flutter project, so I thought it would be nice to do these tutorials as I go. As you can see, it's built a little different. You have your native code, which widgets are rendered, and you have platform channels, which communicate with the hardware. There's no JavaScript layer here. We will have to learn Dart programming, so the first few set of tutorials out of this whole series will be nothing but Dart code. If you are a veteran programmer, Dart is very quick and easy to learn. If you are a new programmer and this is your first language, don't worry. I'm going to step you through this, but we will move at a pretty quick pace. So if you need help, definitely go out to my website, go in contact, and be sure to join the Voidrums Facebook group. There's 1,700 programmers out there who can help you. And I should note that the source code for this and all tutorials will be out on GitHub. There's a link to my GitHub repository out on voidrums.com. All right, so first thing we need to do with Flutter is actually install it. So we're going to select our operating system. I'm on Linux. I have Mac OS and Windows, and I gotta say they're all just dead simple to install. The first thing we'll need to do is actually make sure we have the system requirements. Do I have X number of space? Am I running this platform? Do these commands actually work? Yes, they do on my case. So without further ado, we're going to get this. Make sure I don't already have it installed. I do not. But you can see I already have Android Studio installed. I'll be developing on Linux. However, you can develop on any platform you'd like. Just know that I will be targeting the Android projects. All of the programs that we write should also run on iOS, and I may actually do some iOS programs simply because I have a Mac and I like playing on it. But to start off with, you should already have Android Studio installed, and you should have the IntelliJ Community Edition IDE. Now, when you go to JetBrains.com, and you go to download IntelliJ, there's a couple different versions. Ultimate Community. You want Community because it's free. I'm not deterring you from buying it. You can go ahead and spend money, but I will be using the free version. That way people all over the globe without any money can follow these tutorials. All right. So back to what we were doing here. First thing we need to do is actually grab the code. So we're going to just copy that, paste it in there. And if you have no idea what this is doing, we're using a program called Git, which will clone the source code or the repository from GitHub, and that's the actual link to where we're going. You can actually follow that link and go out and browse all the source code for Flutter, but right now we're just going to install it. And this will take just a moment to download. Once this is done, you're going to want to actually set your path, and it walks you through here step by step. Now, notice this command is only a temporary workaround. You're going to want to follow the directions for your operating system to make it permanent. See, what happens is if you just do this and nothing else, when you log off and log back in, it suddenly doesn't work. To test this, we're going to do Flutter Doctor. Not Fluster, Flutter Doctor. I have got this wicked cold, and it is just messing with me. These cold meds are just making me really loopy. All right, so you notice the first thing Flutter Doctor is doing is downloading the Dart SDK. So if you're working with Dart, know that Dart is a language in itself, and while this is downloading, I'll just discuss Dart a little bit. Dart is a full-blown language. It's not just for Flutter. You can actually use Dart to create web programs, mobile, and a Dart VM or console server applications. My hope is that someday they will actually put like I want to say like a desktop GUI over this, sort of like C++'s Qt, where you have, buttons and list views and things like that for desktop applications. I think that would just be amazing. So let's check on this. As you can see, it's downloading the SDK, it's building the Flutter tools, and downloading all the other little things that it needs to run. And at the very end, you get this scorecard. Now, if you don't have checkboxes next to everything, you're going to want to investigate what's wrong. And most of the time, it'll tell you flat out what you need to do. That's what I love about Flutter Doctor. So if Flutter ever acts a little screwy and you think it's not working right, just run Flutter Doctor and see what it has to say. Generally, you're going to get an output like this. Flutter on whatever operating system. You have the Android toolchain. On iOS, you'll see both the iOS with Xcode and Android. You have Android Studio with a specific version. Now, when I say specific, it should be newer than a certain version. And it tells you the Java OpenJDK runtime and the IDE. Now, notice how it says Flutter plugin, Dart plugin. You probably will not have those. And what we'll need to do is go into IntelliJ. And go into settings, and you may not have this window, especially if you just installed it. Close that. I'm just going to say new project. That's not what I wanted, actually. Let's go settings. I was trying to bring this up. If you have just the generic, you've never opened this before, you may see a different window. So get into settings however you can. Go to plugins. And if you don't already have Dart and Flutter in there, click on Browse Repositories. And you'll want to type in Flutter. Mine, there's no button, but you'll have a button here that says either install or update if you already have Flutter there. So to go ahead and install it, you'll probably have to restart the IDE. And you'll know that it's fully working when you see it in here, and when you can say File, New Project, and there is a Flutter and or a Dart icon here. So to begin our applications, I will actually be working with Dart. Notice how the Dart SDK is actually inside of Flutter. So go ahead and set up the Dart plugin for your IDE, and don't worry about this Dartium. Honestly, I'm not really sure what Dartium is. I think it's like kind of a help binding. But we're just going to be working with the raw SDK at first to learn the Dart language, and we'll be using console applications. Then, when we get into more complex apps, we'll actually be switching over to Flutter. So, what we have here is just a generic hello world kind of thing. As you can see, there's a lot of folders. You have an IDEA folder, you have Android folder, an iOS folder, a lib with main.dart. Main.dart is actually the index or entrance file. Basically, you need the main function inside of main.dart to run your application. And we're going to go over all this stuff in future tutorials. So if this looks really crazy, don't worry about it. We're going to cover it. So to recap, you're going to want to download and install Flutter. You're going to want to get a little familiar with the Dart language page. We're going to actually be going over the language tour. Or maybe if I can find it, cold medicine. We're going to go over this pretty in depth. We're not going to spend 3 weeks talking about what is a variable. We're going to step through it fairly quickly, but there's a lot of information to learn. And I think it's going to be fun. Whoops, I was dragging and dropping something there. All right. Questions, comments, concerns, please be sure to join the Void Rooms Facebook group and leave me a note out there, and I'll talk to you guys later. Hey everybody, this is Brian. Welcome to the second Flutter tutorial. I know it says Dart here, but before we really dive into Flutter, if you remember from our previous video, we actually have to learn the Dart language first. Don't worry, it's pretty painless. So we're going to just click on language. We're going to go to tour, and this is what I'll really be working from, although I won't be following it verbatim, but I want to definitely point you to where you can find additional information here. So, tour of the Dart language. They walk you through what is a basic program, and we're just going to actually open IntelliJ, create a new project. We're going to make a new Dart console application, and let's call this VarTest. Whoops. Just because I'm horrible at naming projects. And this will take just a second to load. I actually don't know why this is so slow. I have just an ungodly amount of RAM and 2 solid state drives. This is actually my PC I use for video gaming, so I'm not sure why this takes a while. But while that's sitting there churning in the background, what we're going to really cover in this tutorial is what is a variable, what is a constant, what is a final. There's a distinction there, and it's a little tricky. And then some of the built-in types. You can actually click on that built-in types, and you'll see there's numbers, strings, booleans, lists, maps, runes, and symbols. Not going to really cover these last two, but you can definitely look them up in the official Dart documentation. All right, so now that we have got our brand new shiny program, let's just run this and make sure everything builds correctly. If you followed along and you've got the same setup as I do, you'll see Hello World 42. That's actually kind of funny. It's funny because of a book by Douglas Adams called Hitchhiker's Guide to the Galaxy, where the ultimate answer to everything was 42. So we're going to remove that import statement and remove the print statement. Just save and run it again, and you should have absolutely nothing there. That'll be a good starting point for us. Now, structure of a Dart program. You can see how the main.dart file is in the bin, and this is our main statement or our main function. This is the entry point to the application. So we're just going to say print hello world. What we're doing here is we're calling a function. You've probably seen this in other videos, and if we just save and run, you'll see, sure enough, it says hello world. But what's really going on here under the hood? We have a function, which we're going to cover in a future tutorial, that works with something called a variable, which is right here. Hello world is actually a string variable. So what is a variable? A variable is simply something that will change over time. So variable is actually a scientific term, something that will change over time. So we're just going to say var something. Whoops, if I could spell, hello world. So what's really going on under the hood is Dart is creating a new variable with that information in it. So this and this are exactly the same thing. You can save, run, and it does literally the same thing. To kind of drive that point home, you can actually press dot after hello world, and you see it brings up all of the other functions in the string class, which if all of that sounds like voodoo nonsense, don't worry, we're going to cover all this in future tutorials, but you just need to understand that a variable is something that will change. To drive that point home, you can say, oops, hope if I spelled something right. Cat's rule. Now, if you're a dog lover, you can put dog's rule. I won't come find you. But point is, we've changed this. We've made changes to it. Now, on the flip side of that, a constant is a scientific term that means it is constant. It will never change. So we'll say const. What do we want to put here? We'll just say nope equal 1. So if we try to take our nope variable here, and or I should say nope constant, and make this a 2. Notice how there's got that little red underline and it starts complaining, and if we even try to run it, it's going to crash and it's going to say cannot assign to final variable nope. Now what's going on here? We call this a const, but it says final variable. So there's a little bit of information you need to know, and I found this really great article. I'm just going to put this right in the code. But the difference between final and const is it's tricky to understand, and you won't really get it until you really get into the language. But I wanted, right up front to tell you there is a difference. If you're writing your code and you're following along, say, in another book, and you say final noper 1, noper equal 2, essentially you're doing the same thing, quote unquote. You have something that you cannot change, and it's going to complain every time, and if you try to run it, let's comment that out, you'll see that, yes, it still crashes. Cannot assign to final variable noper. Okay. Let's comment that out. By the way, if you don't know what a comment is just something that the computer completely ignores. It's there for your enjoyment, if you will. A lot of times programmers will comment code as they go so you can understand it, not just from a machine perspective, but from a very readable human perspective. So anyways, back to this. Variable is something that will change. Constant and final cannot be changed. So what's the difference between constant and final? This article sums it up the best. Ignore static for now, but final means a single assignment. A final variable or field must have an initializer. What does that mean? Basically, it means that you have to give it a value. So for example, if we just comment that out, you can see how, it must be initialized. You must actually give it an initial value. Let's try the same thing with nope here. Notice how nope is also complaining must be initialized. So you understand what an initializer is, and because it's a constant or a final, it has to have a value starting up. Once assigned a value, a final variable's value cannot be changed. Final modifies variables. Basically, it takes the variable and sets it in stone and says this will never change. For example, a constant would be the sun. Unless it explodes, it is a constant. It will never change. Or I should say it's a final. It'll never change. A constant, however, has meaning that's a bit more complex and subtle in Dart. Const modifies values. Notice the distinction here, values. Final modifies the variable where const modifies the value. When you look at these two real quick here, this is the variable, this is the value. So let's go back here. A final modifies the variable. So final modifies this, the variable, where const modifies the value. So you can pass that constant around to other constants. It will always remain a constant, but you can pass it around with a different variable name, whereas a final is final. That is the only time that can ever exist in that. So if we try to do a const noper, see how we're getting an argument. Noper is already defined. You're going to get that anyways, but that's really the distinction, and it gets really deep, and like I said, you're not going to truly understand it until you get really good with Dart, and you end up in those cases where you need to understand the difference between the two. But I'm going to take this article and throw it in here just so we kind of have that as a reference. Whoa, what is this? Cancel. All right, so which one should you use? I use const just because it suits my needs. And until I get into complex applications, I won't really need to know the difference. Now, if that's not confusing enough, there is that other one called static, which we'll get into in future tutorials, which really deals with classes, and that's why we're going to cover it in future tutorials. So onward. Now that your brain is completely numb, just understand there is a variable is something will change, and a constant or a final will not change. Changeable versus not changeable. In this tutorial, we're going to be working with things that change, or variables. There's different variable types. Notice how in the front I put var, or const, or final. That's the type. Well, there's a lot more types here, so we're going to get into numbers. And they are, well, numbers. Yeah, exactly what you think they are. So we'll say num, and we'll say age equal 12. Why not? Now, if we type age and hit the period, you see that we go into that class's scope and we get a whole lot of functions. This is a lot of built-in functionality. In Dart, everything is an object, much like in Java or other languages. So because everything's an object, you can actually go in and get reusable code, something somebody else has already written. Like we can round, we can double, we can convert it, floor, ceiling, ABS, to string, is it not a number, etc., etc. Now notice here on the right, you see some words like int, double, string. What are these? Well, that's the return type. So that function is going to return a double, where this function will return an integer. So you know automatically what you're going to get. So as you would expect, because this is a variable, well, let's add 20 years to this. Let's add 30 years to this. Why not? We're going to just print the age out here. So you can see how now it is 42. And I'm kind of doing this on the fly here. So you see how it says age is 42. If you put the $sign inside, you can actually reference a variable outside. If that makes no sense, let me repeat it. What we've done here is we've created a string variable, but inside that string variable, we're referencing an external variable called age. See how that works? Otherwise, what you would need to do is actually go, whoops, plus age. Now, notice how the argument type num cannot be assigned to the parameters type string, because this right here is actually a string. If you hit the period or the scope operator, you will see that you have options or functions from that class that you can choose from. So we actually got two variables we're working with here, this variable and this variable. So it's kind of a matter of preference. Some people like doing this, some people like doing that. Do what's comfortable to you is really what you should do. And just in case you were curious, if you're going to do it like this, you just say age.toString, and it converts it to a string for you automatically. So you can actually, let's do like this. And we'll run it just so you can see age is 42. I'm going to put it back the other way, just for the purpose of this tutorial though. So I actually got a little ahead of myself here. So a boolean, we're going to actually jump backwards in time here, and we're going to say bool is working equal false. A boolean is like a light switch. It's either on or off, true or false. And we're going to say is working equal true. Booleans are very helpful for certain things. Like, for example, let's go back to our age example here. If we want to say is infinite, is age infinite, it's going to return a Boolean value. And it's going to tell us whether or not that number is infinite or negative or finite. All right, let me check. Oops, somebody messaged me. That's the problem with doing videos real time. I don't edit my videos, so you'll see and hear a lot of craziness going on here. One thing we should really be aware of is that there is more than one type of number. For example, an int would be, let's say, cats, the number of cats I have. I actually don't have any cats right now, so I'm lying a little bit. And then there's a double. And let's say pi equal 3.14. So what's the difference between an int and a cat? These are big, 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 big numbers. You can actually go out to the Dart documentation, and you'll see integer values generally be between negative 2 to the 53rd power to 2 to the 53rd power. That is a huge number. Where a double is a 64-bit double precision floating point numbers as specified by the IEEE 754 standard. Whew, that's a mouthful. Basically, what you need to understand is almost all numbers that you create are going to be converted either into an integer or a double, depending on what they are. But both integer and double actually inherit from the number class. What does that mean exactly? Well, what it means is that if you say age dot, you'll see all these things like round to double to int to floor, blah, 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 blah. What inheritance does is if we say cat dot, you'll see that it's inheriting all of those, plus it adds a few little extra. So an inheritance is, think of, back to scientific terminology, you inherit your genes from your mother and your father. Everybody does, unless you were born in a laboratory. But anyways, we won't get into that. So you have parts of both your mother and your father. So, for example, an integer has parts of num. A double has parts of num. Pretty simple. We'll cover that more when we get into our classes tutorial, but just understand that there's essentially two different types of numbers. There's integers and doubles, and you can use the generic num if you don't know what type of number it actually is. See, it won't break anything if we do that, but if we try doing that with an integer, it gets a little angry at you. It says it has to be a double. All right, now we get into the really fun stuff, strings. I don't know if you guys can hear that. I'm in Michigan, and it's just starting to get cold and snow, and my neighbor is now just trying to get their leaves up, and I can hear them like yelling at each other. It's kind of funny. So we'll say string title equal hello world. So what is a string? A string is a sequence of characters. What is a character? A character would be these individual letters. Now, you should note that I think there's 200, we're on the internet, so somebody will correct me if I'm wrong, 255 different characters. Not all of them are actually human readable. For example, the space is a character, a tab's a character, zero, not the number zero, but just nothing is a character, things like that. So a string is a sequence of characters. Now, if you want to work with Unicode, spoiler alert, you'll need to work with something called a rune, which we're not going to cover specifically in this tutorial. We may cover it in future tutorials if there's like a huge public outcry for it. All right, so you get now that it's a sequence of characters. What can you really do with this? I mean, what does a string really let you do? Strings let you do a whole lot of really, really cool stuff. For example, you can say title equal, oops, my kittens. Just why not? I had no idea where I was going with that. And we're just going to say print title. So you can actually build strings. There is a class out there you should use called a string builder if you're going to actually start building strings. It's much more efficient than working with a string directly. But for this tutorial, we're going to just cover strings. All right, so back to this. What do we want to do? Let's say we want to play around with this thing. And let's actually... So we're just going to have this say hello world right here. Let's say we want to know some values out of this thing. Let's say we want we want to extract part of that string, substring. So we want the start index. Let's say we're going to start at 0, and we want the first 4 out of this thing. Let's run this, and you'll see that, ta-da, nothing happens. Because we're not actually changing this variable. We're actually calling a function that's returning a variable. So let's grab this. And you'll see the first 4 is, whoa, that's kind of dark. I didn't mean to do that. The first 4 is hell. Sorry, ladies and gentlemen. But what we're doing here is we're grabbing a substring, or the first 4 characters. Now, you can see how the 4 characters are outlined there. What is this 0? Well, under the surface, this is really a list of characters. We're going to cover lists here in a few minutes. But lists are zero-based indexes, meaning it starts with a 0 instead of a 1. So this position right here before that H is 0. 0, 1, 2, 3, 4. That's how you get those 4 characters. So substring starts with a 0, and then we tell it how many characters we want, or you could start at a different one. So for example, let's say we start at 1, and now we're going to get some gibberish eel with a space. That's not a good example. Let's do 2. That's really not a good example either. Let's grab 5 characters. Why not? Hello. So you can see. Oh, you know what? We should cover other things as well. Let's put this back the way it was, just so I can really freak people out when they download this code. And let's say we want to. I'm really doing this video on the fly here, so bear with me here. We want to replace all. So we're going to say title equal title.replace all. And we want to get rid of the L's, the uppercase L's, anyways. And replace those with Z's. As you can see, we've got these 2 Z's in there now. Pretty neat. Now, one thing you can really do with a string that's kind of interesting is you can play around with it. So we're going to say string book my world's issues in a day. What have we done here? You notice how instead of using single quotes, we're using double quotes. You can use those interchangeably. It doesn't really matter. And you would use those for specific instances like this, where you want to put a single quote in there. This could also be written as, let's say, string book 2. Notice how it's got that slash in front of the single quote. That's called an escape sequence. You would use that for specific things. Like, for example, this is a single quote. So anything after the escape is the sequence we're going to inject into the string. For example, let's say we want to do a /n, which is a new line terminator. So let's print these 2 out. We're going to print book, and then we're going to print out book 2. Just so you can see the difference here of what we've done. And you can see how my world's issues in a day and then my world's issues hard return are actually new line in a day. Now on some platforms, like Windows, I think it's RN instead of just N. So it gets into some platform specific stuff there, but you can see that really it doesn't matter whether you use single or double quotes, and it's kind of personal style and preference on which one you use. All right, so now let's get a little different here, and let's say string names equal just going to make some names there. And we're going to assert something. Now assert is a special function in Dart that will say this must return true. Whatever we put in here has to return true. So we'll say names dot dot contains, and we're looking for Heather. Probably help if I put that at the end there. Notice how each line has to end with a semicolon. That tells us that we are at the end of the line. Very funny, huh? So when we run this, nothing happens, but we've done this assertion. So let's say just random junk in here, and we try to run this now. Notice how it'll error out. Names contains whatever is not true. So that'd be a good way of testing your variables. Let me put this here. So we're going to talk about lists next. Lists are, well, list of objects. So we're going to say list. And you notice how the IntelliSense pops up and it says there's this weird bracket with an E in there. What was that? Well, this is called generic programming, and what it allows us to do is reuse code. And we're going to get into this in future tutorials. Just right now, understand that we have to give it a value type, or I should say a variable type, sorry. In this case, string. So we're going to say list equal names.split. Split's going to take a pattern, and we're going to split that based on the comma. So what are we really doing here? If we examine names.split, you can see how it's returning a list with string. So a list is going to be a list of objects. In this case, we want a list of strings. We very could easily have said integers or doubles or even, var if we don't know what type it is. Actually, I don't think it would allow us to do that. But in this case, we're just going to use a string. So think of a list like a, what's a good example here? Think of a list like a shopping cart. Shopping cart, you just throw anything you want in there, but we're saying a specific type of thing. So in our shopping cart, you can only put strings. We don't want to put integers or doubles or anything else. We only want strings in there because we're going string shopping, if there is such a thing. So from our list, we can then pull items back out. Or we can just examine the list. So let's say we want to know what's in our list. Save this and run it. In our list, we have Brian, Heather, Chris, Carl. Let's say we want to get the item at, or I'm sorry, the element at the second index. Because remember, a list, we talked about this, is zero base. So the second one, 0, 1, 2, is Chris. Now, you can also shorthand this, as most people do, and say list bracket 2. That way you don't have to do the element at. It does the exact same thing under the hood. You see how we got Chris there twice now. Now, from here, let's say we want to add to our cart. We want to add a string here. So we're going to add Bob. Bob's been a good boy. He can go into our little shopping cart of strings. And let's print our list out again. And you can see we now have Bob at the very end. Now, let's say we want to add somebody, but we want to add them in the list, not at the very end. So we're going to actually say insert. Notice how it's wanting an index and a string element. So insert, we're going to insert this at the first position. And we're going to call this, I need a name. I need a good name. Back to our Hitchhiker's Guide to the Galaxy, let's just say we're going to add Ford. I should have added Slarty Bart Fast, but yeah, let's actually do that. He's a character in the book. I love that book. It's funny. So then we're going to print our list out. And you'll see how in the first position, because it's a zero-based, 0, 1, we have now added or inserted Slarty Bart Fast. So what if we want to know where something is? Let's say we want to print. I can't type. Let's say we want to know the index of, let's say, Carl. Ooh. Why did that return a -1? Let me play around with this for a minute. Did I misspell something? There we go. So Bob's at the 5th index. Why did that say 0 or -1 for Carl? That's weird. Obviously, I have a boo-boo somewhere. That's interesting. I'll have to figure that one out. But basically, index of gives you the position of where they are. Let's actually play with this a little bit here. Figure this out. So we're going to say there's a little function in here called for each. And what for each will do is it will list out every single item in the list. And we're going to say for each give me just a second here. If this looks like voodoo magic, I will explain this in just a minute. Oh. Semicolon expect. Oh, derp. Derp, derp, derp. Alright, that's what's going on here. So, if you look at our list here, we've got Brian, Slarty Bartfast, space Heather, space Chris, space Carl, and Bob. That's the problem. That's what's going on here. Remember how we split it based off of this. So what we should try to do here. What is the name of that? Was it trim? No. Let's just do this easy way. I'll have to look it up, but I swear there was a function in there you could do that. Let's remove those, the spaces in there, right? What I was looking for here is names dot trim. Trim will remove the blank spaces. I was hoping to do that per item, but I think it's going to be more of an advanced topic. I've also got a cold, so I'm not going to really fight through the cold medicine to do it. So when we run this now, you'll see how there's no spaces in there. And if we go back to putting Carl in there, I think Carl was throwing an error, and so was Heather. You'll see now that it is at position 4. So back to this list for each. What in the world are we doing here? So we're taking our list, which is this thing here, and we're saying for each item in the list, and then we're doing a anonymous function, and we want a v, or a variable, and we're going to print that. I know this is a bit of an advanced topic for people that are brand new to the language, but those of you, really gridiron veterans who have worked with multiple languages are probably loving me for this right now. Just know that you can do these kind of things with Dart language. That was makes it so elegant and so nice. And it makes troubleshooting things a little bit easier too, as you can see. So, anyways, finally, maps. Maps are a little bit different. We're going to say map. And we want to give it, once again, we're doing generic programming here. We're going to say string and an int. And we're going to call this ages equal. And what a map is you have what's called a key value pair. So we're going to say Brian and 43. Man, am I 43? I'm getting old. I was just playing Call of Duty. That explains some things why I was just getting completely smoked on Call of Duty by some of these players. Literally, like, I shot a rocket at some guy and he just laughed at me and like stabbed me in the face with a shovel. So it was not fun. I actually thought about just uninstalling the game at that point. Fortunately for me, though, Carl also plays video games and he is older than me. So thank you, Carl, for being my friend. Anyways, so what we're doing here is we're actually building a map or a key value pair. Uh-oh, somebody's texting me. This looks important. You can wait just a minute. So the key value pair is going to align up. We have the key and we have the value. And in here is our actual map. Now, it's called a map because you actually have two lists under the hood. These names are a list, or the keys, and these values are a list called values. So let's just say print ages.keys. You'll see Brian, Heather, Carl. Brian, Heather, Carl. Those are the keys. Notice how it's a list. Now, let's say print. Whoa, did I hit caps lock? Sorry for yelling at you guys. Print ages dot values. So you can see how we have two distinct lists here. So what a map does is map those or correlate them. This one maps to that one. This one maps to that one. That's why it's called a map. All right, so how do we work with this? How do we really extrapolate data out of this thing? Well, let's say we want to get the value of one of these keys. So we're going to say print ages, and then we're going to say Brian. My throat's getting a little sore. I've had this nasty cold, and it's just really driving me nuts. So there's 43. So you can see how Brian maps to 43, and we've got the value of Brian using that key. We could also do something like this, and we could say ages.keys at element 0. So we want to get the first one. Whoops, maybe that isn't really working well. Isn't defined by... Really? I thought I could do that. Element at. Let's do it this way because I said so. And it does the same thing, basically. But now I really want to know why I couldn't do this. You think you could do this? Did I screw something up? It's probably because it's got these double blocks. Which leads me to my next point. It's just a fairly new language, so things will evolve over time. I expect something like that would actually function at some point. Right, so how do we actually add in here? So we're going to say ages dot, let's say ages, give me a name, Mark, equal Mark's in his 50s. So we'll say that. And then we can print ages Mark. Let's save and run this bad boy. And you can see there's Mark in his 50s. Now, just for giggles, let's say we wanted to do something like we did with this list here, where we do a for each. So we're going to say ages.for each. Notice how it has string int, fat arrow into void. If you have no idea what I just said, we will cover all of that, I promise you, in future tutorials. And for this, we're going to say k and v for key and value. And we, of course, because this is all one statement, need to end that with a semicolon. That looks crazy nuts, doesn't it, if you're used to other languages? So what we're going to do here is we're going to say print and then do this. So you can see that for each item in our map, we're saying key is value years old. So Brian's 43, Heather's 24, on and on and on. Pretty neat, pretty simple. So that in a nutshell is working with variables. And I realize we kind of got off base on a few areas. I apologize. I've got this bad cold medicine going on. But if you ever want to know more, you can definitely go out to the Dart Lang page, dartlang.org, and look at the Dart language tour, and definitely check these out. One other thing you should know is you can click on libraries, tour of Dart libraries, and you can see the built-in libraries, Dart Core as it's called, and you can get much, much more information out of all of these things. You can get some really good examples. This is something I really have grown to love about dartlang.org, is it has all this information baked right into the web page, so I don't have to spend 5-10 minutes, looking up on Stack Overflow or Expert Exchange or anything like that. You can get a lot of great info out here, so definitely check this out. That being said, thank you for watching. I hope you found this educational entertaining. And before you go, the source code for this will be out on voidrobes.com, also on GitHub actually. There's a link to it on my website. And be sure to check out the Void Realms Facebook group. There's 1,700 other developers out there. And that's it. Hey everybody, this is Brian. Welcome to the third Flutter tutorial. Just posted the first two the other day, and as you can see, I've already got a few hundred on each one in comments and some thumbs up. So everybody seems to be really interested in Flutter, so we're just going to continue on down the path here. Now, to back up, we have to learn Dart before we can learn Flutter. Looking at the tour of the Dart language, you can see how they kind of, if you go in, they cover variables, keywords, variables, built-in types, which we've covered. But then they jump to functions, which if you're new to programming, really doesn't make a whole lot of sense. If you remember, a variable is something that'll change, where a const or a final is something that will not change. A function is a way of organizing that into a logical group, but you haven't yet used variables. You don't really know what to do with them. So we're going to actually skip down to control flow statements. So control flow statements are exactly that. They control the flow of a program. And the first one we're going to cover is if and else. So let's just crack this open here. We're going to make a new Dart console application, and we're going to call this flow1. And while that is thinking, we're going to skip back here. So some of you may be confused and go, why are you jumping to control flow statements? You're not talking about functions. We're going to talk about functions after we deal with control flow statements. The reason being, you know what a variable is, like I said. Now you need to know what to do with the variable. It's something that will change, but how do you handle that change? What do you do when the change occurs? So that's what we're going to really cover today. So let's just get rid of this and get rid of that. Once again, the structure of our application, we have got our main.dart in here. And if you're wondering what this lib is, this is just part of that demonstration code that let me undo all this. It's part of that demonstration code that comes with the template. Really, they're just importing this, which we're going to cover in a future tutorial. But for right now, you can safely ignore it. Now, if you go back to our previous tutorial, you'll see that, ta-da, there is a variable here called arguments. So this main function already has a variable, so something's going in here. An argument is something that is passed to your application when it is first started. Something we're not going to really be dealing with, but just be aware that that's there. That's how you can tell a program, start just normally, or start and open this file, that kind of thing. So if and else, whoopsie, cannot type. So let's make a variable here. Let's say bool is on equal false. So we have a variable, and we're going to say, let me actually just jump down a little bit so it's easier to read. If, and then you have these parentheses, is on equal. Notice there's two of those. Now there's a bit of a heated debate in the programming community, and I'll get to this in just a second as I can't multitask today. It has to do with the brackets here. This is what's called a C style language. C is probably the grandfather of all languages. Well, not all languages, but all C style languages. C was meant to make assembly easier. C is actually kind of challenging, but so you have these brackets, and this denotes a scope or a block of code. You notice how there's two of them here. You notice how there's here and here. And actually, in this IDE, if you click on one, it shows you where the ending one is. So there and there, there and there. That's your scope. So what we're really going to learn right now is two quick things. First is variable scope, and what is the if and else statements. But the religious battle, if you will, is where to put this little bracket. Some people like putting it down here. Some people like putting it up there. Now, when I say up there, what I really mean is you take this and you put it on the same line, like that. It doesn't really matter where you do it. Some companies have coding guidelines and standards that you should really follow. But just know that you need a start and end bracket to denote scope. So what is scope? I'm glad you asked. Okay. So let's make another var. Let's call this var kitty. equal, I don't know what to name a cat. Let's just call it cat. Why not? So let's run this, see what happens. It is off. So we've got our variable, bool is on equal. Notice there's only one, false. If, so this reads like a statement here, if, and then we have our parentheses. This goes back into arithmetic where you have to multiply and add things. So you'd say 3 plus 2 plus 6 equals, whatever, right? What's ever done in the parentheses is going to be calculated first. That's why it's in parentheses to begin with. So we know that this is going to be evaluated. Now, this is an evaluator. Actually, this is a, drum roll please, operator. And it is an equality operator. And you can read a lot more here. So you see how there's two of them. Now, why wouldn't you put one? Some of you old programmers know what I'm talking about. If you do that, what you're really doing is you're assigning the value, much like you're doing up here, is on equals false. So when you do the double, you're saying is on is equal to, if is on is equal to whatever the value. So that's why it says it is off. Now if we change this to true and run this, it is on. So you can see how you have control flow here. This statement is being executed because it is true. If we flip it back to false, then this statement will be executed along with this variable being created. So let me add some comments here. Inner scope, outer scope. Did I misspell outer? That'll be embarrassing if I did. I don't think that's outer. That's otter. Anyways, it's not even otter. Man, cold medicine, I'm telling you. So scope, anyways. Scope goes in a logical order, or you should say top down. So for example, is on, notice how we can actually access it here. Let's actually do it like this. And let's actually just copy this here. Run this. So is on equals false. So we can access this variable in this scope or in this block of code. What happens if we try to access Kitty? Notice how IntelliSense isn't helping us out, and it's saying object, meaning it doesn't know what the hell we're trying to do here. And it's complaining, and it's saying, hey, unidentified name Kitty, but we have it here. That's called scope. And true enough, if we try to run this, it's just going to say blah, no top level getter for Kitty. What's a getter? We'll cover that in a future tutorial. However, just be aware, Kitty is out of scope. So where is Kitty? Right here. Where's the scope? Right here. We can access Kitty just fine as long as we're in that scope. Once again, is on, this variable, probably horrible variable name, is in the outer scope. So it's available to anything in a subscope. Subscope being a scope declared within this larger scope. Whew, that gets confusing. So let's go over that one more time. We have our outer scope here. In that outer scope, we have subscopes. Kitty is defined within a subscope, so it is not accessible in the outer scope. However, variables described in the outer scope are available on the inner scopes. Is that even the right way to say it, inner scope? Somebody correct me if I'm wrong. But if we simply move this print statement up here, we can see it runs just fine. So that is a very quick lesson on if and else and is on. So what's the difference between if, else, and, scroll down here, whoa, we went way too far. Else if, you'll see this a lot. What's really the difference here? I just stuttered, that was embarrassing. Anyways, the difference between if, else if, and else. Let's figure this out. Let's just, through the magic of copy and paste, change this around a bit. Actually, no, I want to keep this as an example. Let's say int test equal 1. Why not? Why are you indented? I don't like you. All right, so if test equal, let's say 2. Now, if you're going to choose a bracket style, you should be consistent in that style. And you should probably put it in the print statement, Brian. All right, so we've got our little else here. And we can even break that down further like this. I'm kind of like an indentation snob, if you will. I like it a particular way. Else, and we're going to just say now from our scope conversation, we know that we can access this variable because it's in the outer scope. So let's run this. So test is 1. So this got executed, not this. So let's just copy this again and see what happens. Notice how we're getting an error already. Expected a statement. What's going on here? Line 30, position 3. So we're at line 30, position 3, because we're 3 spaces in. Unexpected token else. But if we say else if up here, what happens? It breaks. So let's look at this and see what we're doing wrong here. We have our if. We have our else if. Now, this is what we're missing here. So we have to notice how all the errors suddenly clear up. And let's just, so we know this. Run that. So test is 1. Because test is 1. Confused yet? Don't be. It's just a way of chaining if statements. You have an if statement here, an if statement here, and if neither of these actually apply, then do this. That's really all that does. Now, there is an easier way of doing that, or at least a more elegant way of doing that. But before we cover that, I want to talk about comparisons in the if statement itself. If you read their disclaimer, it says, remember, unlike JavaScript, Dart treats all values other than true as false. See booleans for more information. Sometimes people will say things like test equals 0, and then instead of that, they'll just say test, if test. And you notice how it must be a type of bool. So it's got to go into a true or false sort of statement. It's pretty easy to do that, though. So now we're going to cover what's called the switch statement. It's called switch in case, and I think that'll probably wrap up for this tutorial. So this looks just horrendous. What is this thing? Okay, let's break it down a little bit. You've got switch. Now think of this as a giant switchboard on off, right? You've got a dozen switches in front of you, and you can flip each one on and off. So here's the variable. So we've got var command, and then we've got our evaluator, the parentheses, and then we've got a scope. So within this scope, we've got a bunch of cases. Now think of these cases as shorthand for if else. We're going to rewrite this whole thing. So using the test, switch, test, and there's our scope. Notice how what we're not doing is testing for equality or inequality. Like we're not saying, not equals or is equals. We're just saying we're going to switch on this test. Now we've got a bunch of switches, and we'll say case 0, break. Case, let's actually back out here, case 1, break. What is going on here? Well, let's find out. Nope, test is not 1, test is 0. Derp. I hate having a cold. I feel so just out of it when I have a cold. It's finally going away, but man, what a long road this has been. All right, so you can see up here our variable is 0. So what's going to happen? And let's actually define this out here. Switch. That way we can really see what's going on when we print these out. Run this bad boy. And you can see switch test is 0. So really what we're doing is pretty much the same thing. It's just we don't have all this if-else gobbledygook. So this monstrosity right here is the same thing as saying case equal 1 inside of a switch. So here's our switch. Here's our switch. Now, one thing you should know is there is an invisible scope here that you don't really realize. So let's just say var dog equal Sam. And then we're going to print Sam. Notice how Sam is going to say undefined object, and if we try to run this, of course, it's going to break. Oh, no, it actually didn't break. Interesting. Probably because it didn't execute. Let's do this. Yeah, now it's going to break. So that's how you'll find some errors in your code. Like if it's working just fine one time, but then not working another time, check your scope. The invisible scope is between the case and the break. Think of the invisible brackets being here and here. Each one of these cases is a little switch, like a light switch, right? So we've got 2 of them here. We are declaring this variable inside of this switch or this case. It's not declared here. Therefore, this code gets executed when it's 0. This code gets executed when it's 1. So if this code's executed, this variable's never created. You see the catch-22 now. So if you wanted that, you would either have to make that in each one, or better to do it up above. Now let's get rid of that and get rid of that. And let's see if this works. Nope, no top level getter for Sam declared. So you'll have to understand that scope here is a little wonky and a little crazy sometimes. So you just definitely want to make sure that you declare your variables in the proper place. Now, why isn't this working here? That's a good question, and honestly, I don't know. In other languages, this works just fine. So why is this not working? Probably because I have the wrong variable name altogether. So let's retest all of that. That was embarrassing. So let's print dog. I may be wrong. I'll be flabbergasted if I'm totally wrong here. All right, so back here, test is 1, so this will execute. Yeah, all right, so, and if we put this here, it suddenly works, but it would be much better to actually put it up above right here. All right, sorry for that little confusion. That's also a good conversation we should have is variable names. If your variable doesn't exist, you're going to get an undefined error, as you just saw. So that in a nutshell is the switch statement. But there is one little question we have, one naggy little question. What is default? You notice how it's case, default. And what does break mean? Well, let's try something here. Let's actually make a case 3, print I'm actually trying to hurry because I'm supposed to take my daughter out to lunch and I am starving, which is probably why I'm making a lot of mistakes here. And then we're going to say default. No idea. Wow, I can't even spell no today. I'm going to go get some food here right after this video because I am just dying. I'm going to go get some hot wings, man. I'm hungry. All right, so we've got our cases here, and we're just going to put a hard return so that it's easier to read here. So we've got our case here, our case here, our case here, and default, which is actually a case. So let's change our test to a different number, something that we're not accounting for, and run this. See how it says no idea. So default is basically a giant else. It's this else statement here. We're going to switch this back to, let's say, did we totally skip 2? We did. That's just odd. Somebody's probably yelling at their monitor going, there's no 2. get rid of dog here. All right, so we've got 2. Let's just get those in there the way they should be. Put that in as a 2. Run it just to double check. Test is 2. Now, let's talk about these breaks. Let's actually comment these out, see what happens. Notice how last statement of case should be break, continue, rethrow, return, or throw. What does that mean? We're going to get into that in a little more in depth in future tutorials, but right now you need to understand what's happening. Break is like hitting the brakes on your car. It stops execution of the code. If we change break to continue, continue statement is which must have a label or as a target. What that's telling us is that we could continue the flow of execution if we wanted to go somewhere else. I actually don't know how this works, but let's say continue 3. Nope, continue case 3. I'm sure there's a way to do this, I just don't know. Continue case is not a word. Yeah, I'll figure that out in a future tutorial, but basically just understand what break is doing is it is actually breaking. So let's get rid of this again and see what it's saying. The last statement of case should be break, continue, rethrow, return, or throw. So let's try return because I know that'll actually work. What is the difference here? See how case 3, the last statement of the case, blah, blah, blah. Let's turn that. There we go. Now it's working. So what's going to happen here? All right, pop quiz, everybody. Based off the current code, test is equal to 2. What do you think is going to happen? Is it going to print done or is it not based off this code? Let's find out. There's no done. But if we switch this, whoops, and rerun it, see how done suddenly appears. So that's what's going on. Break will stop execution, but not return. Return means it actually exits the entire function. Return is actually returning out of this entire function. Actually, out of this function right here. Switch isn't really a function, but I'm going to call it a function. Shh, don't tell anybody. So it's going to exit out of the switch statement and then hit print. So when in doubt, use break, but just understand that that break is there for a reason. Some languages have what's called fall through. So you could actually say this and then this. So if it's case 1, break, case 2, we want it to do this and this and this. So just understand that is a thing and we need to prepare for it, which is why the break statement is there. Well, that is a lot of talking and typing, and I'm going to go get some hot wings with my daughter. Thank you for watching, everybody. The source code for this and other tutorials will be out on my website, voidrealms.com. There is a link to GitHub, and let's just go out there. You can click on repositories, and what I do is I have individual repositories, but then I have a master repository that has the individual lessons in there. These are called submodules, so you may have to use, it may not actually download with a full zip. You may have to actually use Git and pull the whole thing down. That way people can contribute to the code. If I make a glaring mistake and it is out in the world forever, somebody else can, submit it. If you found this even remotely helpful, my website and all this code is actually run purely off donations. You don't have to, obviously, but if you are a company and this is helping your employees learn, definitely donate. Anything that goes above and beyond what I use to run the website actually gets donated to charities. Other than that, thank you for watching. Hey everybody, it's Brian. Welcome to our drum roll. I think this is the 4th. I lost count. Yep, it's the 4th Flutter tutorial. Today's just been nuts, so forgive me if I'm a little scatterbrained. But we are going to pick up where we left off on control flow statements, and we're going to be looking at the while and do along with the break and continue, and we're going to touch on the for loop. So if you're reading along in the official documentation, you can see there is this while and do while. While loop evaluates the condition before the loop, and you can see this nice little example, versus a do while loop evaluates the condition after the loop. that's confusing. So let's look at these a little bit here. So let's say, let's make a variable. Let's call it bool, because I like things indented. While running, we're going to say print. Now, if you're new to programming, one thing you should be aware of is that a loop needs a break, if you will, or it needs to be able to stop execution of that loop. Or what happens is something like this, where it just goes boom, and it just runs forever. You can see down here, it just runs and runs and runs. And to kind of illustrate that, what we're going to do is we're going to make a variable here. And we're going to set counter. If you don't know what that is, it's the same thing as saying counter equal counter plus 1. It's actually shorthand for that. And we're going to say, we'll call this the while counter. So if we were to just run this right now as is, it's just going to count until eventually it gets a Stack Overflow and dies, or until the underlying framework resets that into a 0. Sometimes it'll actually flip it back to a 0 for you. I actually don't know what it does in Dart, but every framework kind of handles that a little bit differently. Stack Overflow would basically be like the whole program just crashes and you get an error message where it will say value out of range or something like that. So what we really need to be able to do here is say if counter greater than or equal to 10, actually say 5 just because I'm lazy, then we will say running equal false. So what we're really doing is we're saying, hey, stop running, but we tell it, hey, set this variable to stop running. Let's run that, and you can see it says while counter equal blah 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 down to 5. So what's going on under the hood here is it's saying while evaluates this expression must equal true, and because we're setting it to false here, every time it reiterates through this loop, it's reevaluating. So when it gets to here and that's false, it just stops. So we can say print onto the next, and you'll see kind of what's going on here. And it says bang, 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 on to the next, and then it just stops. Now the do loop is very similar. And there's our evaluator. And we need to reset that actually. Running equal true. Let's see, counter equals 0. And we're going to actually put in some print statement here. Let's not say waiting, let's say done with while. And then down here, we're going to say done with do loop. And we can actually just take this, and you'll see that it's pretty much the same thing. See? Probably help if we put this as a do instead of a while so it's less confusing. You see it's pretty much the same thing. So why do we need two of them? It's actually pretty simple. It depends on when you want your statement evaluated. Do you want it before or do you want it after? Typically what this will do is it'll take action, then evaluate the statement. I shouldn't say typically, that's exactly what it does. It'll execute the scope of code, then evaluate the statement. Oops, I just screwed that all up. And the contrast to that, the while statement will actually evaluate, and then if it's true, then it'll run it. It's a unique difference. You can get into some pretty special situations. You can actually get into trouble a little bit, like if you have Like if you're doing like socket programming and you're not ready to receive data yet, or you're not ready to send the data, but you do a do loop instead of a while loop, you can get kind of messed up. So just understand the basic differences between that. Um, Essentially, they do the same thing. It's just the order in which your statement is evaluated. Now, this could also be rewritten like this. What is that actually doing? Well, it's doing a few things. First, it's ignoring our evaluator, and it's actually breaking out of the scope. You ever play that game Breakout? That's what break does. Remember how we said it kind of hits the brakes? So it's going to run this scope, but when it hits this break, it's going to say, nope, I'm done, and it's just going to break right out. So which one should you actually use? Well, it depends on your situation and what you're trying to do. You could also say, well, counter is less than 5. I'll actually say less than or equal to 5. And let's do this. We're just going to ignore that whole running variable. Clear a buffer. Now, you can see how things change a little bit here. Now we have up to 6, where we really wanted, because it has this counter in here, we only wanted 5, now it's going up to 6. So you would say, less than 5, run it again, bang. So you see how it really depends on how you structure your code and how you write it. There's really no correct way of doing it. That's the beautiful thing about programming. Personally, I don't like to put this evaluator here. I like to use an actual variable. That way I can check that variable state at any time. And then I like to actually set the variable. I don't like to do the breaks. Personal preference, that's just how I like to do it. Let me make sure this still runs the way we expect it for the tutorials. And now we're going to look at the for loop. For loop's a little bit different. Actually, let's cover continue here. Real quick, why not? We'll say if counter equal 4, then continue. This is the difference between break and continue. Remember how break will break out of the scope of execution? And what we're going to do here is we're going to say, I don't like doing that, but we'll do it anyways. Let's run this so you can see exactly what's happening here. 1, 2, 3, 5. We totally skipped over 4. So what this is doing is we're saying if, and then we're evaluating here, the counter is equal to 4, continue. What continue does is it says, okay, I've heard everything I need to hear. This is a lot like arguing with your wife. I've heard everything I need to know, and I don't need to hear the rest of this. Let's just go back to the beginning. So what this does is it actually says go back to the next iteration and starts completely over. Let me go back up here so you can see it. So in this case, it'll go 1, and it'll go through 2, it'll go through 3, it'll go through 4, it'll go through, hit this, and say, nope, I've heard everything I need to know, and it goes back up here. So this never gets executed. And on 5, it runs all the way through this and says, hey, counter is greater than or equal to 5, and we can actually just say equal to, probably a better, more streamlined way of doing this. Counter is equal 5, then break. Just hit the brakes, I'm done with this whole thing. I'm getting a divorce and I'm leaving you. And it just jumps out and it says done with the while loop. So there you go. Now, back to what we were going to talk about, which is the for loop, which is a little bit interesting. For loop, if you're new to programming, you're looking at this going, oh my gosh, this looks insane. I don't want to type this out. It's actually very simple, and it's very easy to get. And the first 2 times you do it, you're going to get it down the rest of your life. And it's in almost every major language, so here we go. I equals 0. Let's say I equals 0. Notice that little guy right there. And then we're going to say I less than 5 I++. So what are we doing here? What is all of this? Let me put this back up here before people on YouTube yell at me and hurt my feelings. Let's just print this little guy out so we can see what's going on here. And we're saying I 0, 1, 2, 3, 4. So we've done this 5 times. Let's kind of examine this. The for statement actually takes 3 separate parameters. And I almost wish those were commas, but it's just not how it is. And that's a holdover from the old C++ days. So this first one is actually setting a variable. We're going to say we want a variable named I and set it to the value of whatever, in this case 0. Then we're going to say while, because there's actually a hidden while in here, while I is, and then whatever, and we're going to say less than 5, increment I. So here's our incrementer is back here. So basically we have what we want, when we want to do it, and what we want to do to it. And then while that whole thing evaluates to true, we're going to execute. Plus we have our variable from the top. Confusing, but why do we need this? Imagine this. List, and we're going to say string. And we'll call this list equal new list. I have a bit of a sore throat and it's kind of bugging me a little bit here. So that's how we make a new list of strings. Now we're going to say list.add. Everybody always asks me, why do you always put your own name in these? I don't know. It's just because I'm on the spot and I just can't think of names. I'll come up with names like Slarty Bartfast, like I did in the previous tutorial. I just, on the spot, can't think of really anything other than like myself and maybe immediate family, if I could spell immediate family. All right, so let's say we've got a list of people, and in this list we've got 3 people. So, how would we go about doing this? Remember, this is a 0-based index, right? So we're going to say list, and we're going to say I is less than length. And then we're going to increment. So let's just run this and see what happens here. So we know that we have 3 items. First one starts with 0. So what we can actually do here is we can say we're going to try this. I'm not sure if we can do this, but we're going to try it. It might blow up and I may have to put it outside, but it'd be really cool if we could do this. Boom! Didn't do it the way I wanted it to do it. Yeah, let's just put it outside. That way it's easier for people to follow along. So for the sake of the tutorial, this is what we're going to do here. We've got our string, and in there we have our I variable equals, and it's not actually signing, this is just a string, and then we're going to catenate, is that right? Catenate that string with the value of that item. So you can see that 0 is Brian, 1 is Heather, 2 is Chris. I kind of want to figure out how to get that to work. Element at, let's try element at I and see if this actually works here. I'm sure there's a way to do this, and that's why I'm kind of wanting to try it here. Forgive me for just a minute. See if that actually, I don't think that's going to work. Fingers crossed. Nope, didn't do it. All right. Dear Dart developers, if you are, or Dart, yeah, Dart developers would be right. If you're watching these videos, please make that work. That was awesome. I'm probably not doing it right, and there's probably a better way of doing it, but that in a nutshell is how you would do it. Personally, I prefer the shorthand. Get rid of that scope operator there. Same thing. So why do you need the for loop? What's really the difference? I mean, couldn't you just say while we are not at the end? Well, you could, but it's very ugly. So what a for loop replacement would look like we would say, counter equals 0. Let's say, hey, while counter is less than list dot length. I have a nasty habit of putting that on the other line. Counter plus plus, and say print. And here we're going to say we want it to be counter. Actually, let's make it I. That way it's more intelligent here. And I. And I. And let's run this. Ooh, what do we got here? What's going on with this? Invalid value not in range, exclusive 3. So what we're saying here is we have, it starts at 0, and I is less than length. So let's try this. You see why this gets a little hairy here. Actually, let's do this and see if it just runs. Okay, so that does run. And let's get rid of this guy, because that's what's actually causing the error here. And let's just see what we got here. Boom. Oh, see, 1, 2, 3. So we got it in the wrong spot. That's really what's going on here. So we need to actually increment this afterwards. Now it'll run. There we go. So this kind of illustrates some pretty good point. And let's actually put this. So we can see the difference between the two. So we've got our for and then our for replacement. They do exactly the same thing. It's just one is a little bit more complex, a little bit more error prone, while the other is a little more streamlined and elegant and kind of, if you will, industry standard. So if you ever get like a professional job writing code and you do something like this, your quality control agent or your manager is probably going to sit you down and say, why didn't you use the for loop? Because this is exactly what the for loop is designed for. So anyways, those are the distinct differences between them. Just to recap, the while loop evaluates before, the do while loop evaluates after, and the for loop is perfect for going over lists and enumerations. Whew, that was a mouthful. Thank you for watching. If you found this educational and entertaining, be sure to go out, visit my website. All the code is out on GitHub, and I've got a link out to the repository right now. If this was helpful, feel free to donate. This site is run 100% off your donations. Thank you. Hey everybody, this is Brian. Welcome to the 5th Flutter tutorial. Alright, so we're going to jump back into Dart here where we left off. And if you remember, we left off on flow control. And a lot of tutorials start things backwards, in my opinion, where they will talk about a variable and then instantly jump into functions and classes, which make no sense at the time because you don't know what you're doing. So what we've done is we've started with, what is a variable, what is a const, final, and then we've gone into flow control. How do you actually control the flow or the execution of your program? And we did the if, else, for loop, while, break, etc., etc. What we're going to cover now is going to be functions. So what are functions? Believe it or not, you've actually worked with them already. This main right here is a function. Main is actually the quote-unquote main function or the entry point of your program. What I have here is just a new Dart program, and it's straight out of the template here as soon as you open it up. And you see how it's got this int calculate here? That's also a function. So really all a function does is break up or chop up the scope of a code. So we can do things like, let's get rid of this because we haven't talked about that stuff yet. Let's say print hello. Just something simple like that. We just want to print the word hello. Well, print is also a function. Somebody has already written that code for you, and that's how you're able to call it. So let's say we want to print 9 times. So we're going to say for int I equals 0, I less than 9, actually I less than 8, and I plus plus. Let's do this. One, 2, 3, 4, 5, 6, 7, 8. Did I count that wrong? 1, 2, 3, 4, 5, 6, 7, 8. I did. Silly me, I had it right the first time. My brain's fried. Sorry about that. It looked funny. That's why I was like, what is going on here? All right, so we just printed 9 times. We've done this before, and this is old hat. But what we're going to do now is we're going to take this guy and put it into its own function. Actually, let's not call it test. Let's say hello. So what we have here is we've created our own function called say hello. And it has this weird thing called void in the front. A function is always precluded or preceded by a return type. So we can return a variable from this function if you want. Void means that we're returning nothing. It's just void of any return value. So if you see the word void and you're wondering what the heck, to call that, you just simply say the name. Does the exact same thing. What we've done now is we've broken up the scope of this a little bit better. If we flip over here, one of the things is called lexical scope. Dart is lexically scoped language, which means that the scope of the variables is determined statically simply by the layout of the code. And we've talked about this before, right? So like here's your top level, which is visible by everything. That's visible by everything. But the inside function is not visible by that. That's called lexical scope. We've already learned that. So what we're doing now with functions is actually breaking this up even further by saying, for example, this I is not available here. We could even say int age equals 99. And we cannot here say print, age. It doesn't know where age is because of that scope. Age belongs to this lexical scope or this block of code. So if you're still new and you're still trying to wrap your head around scope, that's really what scope means. So what a function is basically taking scope, chopping it up even further and saying, I want this function to exist. And this function will only know about things that are inside of this function or this lexical scope right here. So for example, if I say int age, well, let's not say that, int cats equal, and there's 9 cats. I don't know why I'm fixated on the number 9 today. And here we try to say print cats. Well, guess what? It's not going to work. Undefined name cats, because it's not in the same scope. So let's get rid of those. I'll get rid of that. So that is a very, very bare bone basic example of, you guessed it, a function. Now, what we're going to do here is we'll say, void annoy. We all have that one annoying person, right, in our lives that just loves to talk. And we'll say int times. And here we're going to just say for int I equal 0, I less than times I plus plus. I think my music stopped playing. Did my music stop playing? No, it's just very quiet for some reason. I have to play music in the background or this wireless headset will actually shut down on me. It's kind of weird. So some videos you'll actually see me flip back and forth. But so we've got our for statement here. Very similar, except for instead of just hard coding it, we're doing this. So we're going to say blah. So somebody says hello. Let's actually leave that the way it is. But then the annoying person, annoy, and let's say they come up and they just start talking. Blah, 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 blah. We've got 1,000 blahs in there. I mean, at this point, you just want to like walk away and tell them to go bye-bye or something. So what we've done here is we've actually passed a variable to this. Believe it or not, this is a variable. Some would say it's a value, but remember, everything in Dart is an object. Therefore, that is actually a variable under the hood. This is called a parameter right here. The cool thing about parameters is what we're doing here is we're actually creating another variable, and that variable exists within the scope of this function. You can see how we're accessing it right here. And we can actually say things like, let's get a little funky here. I of my phone made a weird noise that I never heard before. So here we're going to say, what number of the number of times we're supposed to do it, and then they're still talking. So let's just run this again. And you can see, boom. So we obviously have access to this variable. And there's really no limit to how many times you can actually do this. So what we can do here is we can say, void really annoy. And times. And then we could just say, let's grab this. Now this may look a little weird, and I wanted to do this as an example. So let's grab this and let's just comment these out here. So what's going to happen when we execute this code? Well, really annoy is going to get called, which is this guy here. What really annoy is going to do is it's going to actually call annoy, which is going to do this. So it's 5 by 5. You can see how it does this. And it just goes over and over and over again. So that is a function calling a function calling a function kind of thing. You have to be kind of careful when you're writing functions because you have, and some people are going to argue this isn't really the case, but you have a bit of encapsulation. And what this does is this gets a little confusing if you're not used to scope. For example, in really annoy, we have int times, and times is here, and times is here. However, this times right here, while it's the same value, is probably not the same variable unless Dart's doing something under the hood where it, because it's the same value, it moves it in memory and blah, blah, blah. It's not the exact same thing. It's got a completely different scope and therefore it has a different access. So we can actually change this name to blahs. And notice how now we've got to change it here and here. But it does the same thing. So looking at the functions inside of the tour of Dart, you can see there's other things like bool. And of course, now that I'm looking for it, there's void string, things like that. So you can actually make some really cool functions. So what we're doing here is just we're concatenating two strings together, actually technically three because this is also a string, and we're turning a brand new string object. So let's go ahead and do this. Okay, so we have my first name and my last name. And you can see how it just prints out the string Brian Cairns, because what we're doing here is we're calling this function, which is taking two parameters now and returning them as one variable. Now, if you're wondering what types of variables you can return, well, any type of variable, any object actually. You could actually even say var for unknown type. Oh, actually, no, you can't. The return type can't be var. I stand corrected, ladies and gentlemen. I thought you could do that, but you cannot. Which makes me wonder if you can return an object. You can return an object. Okay, so if you have no idea what you're returning, it's just something, you can return an object. But in general rule of thumb is you don't want to do that, because then they have to either know the type or they have to use something called reflection to go in and figure out what type of variable it actually is. Dart is a static type language, meaning that you have to declare your variable types. So let's go back to the tour here. There's some really good examples, and if you're not familiar with any of this at all, you should really kind of just play with some of these and figure out what they do. One thing you can do is default parameter values, and this is really kind of built into almost just about every language here. And what you can say is, your function can use an equal sign to define the default values for both the name and the positional parameters. The default values must be compile time constants. If no default value is provided, the default value is null. Meaning, because these do not have a default value, they are null. Null means there's just nothing there. It's like nothingness. It's like when you lose a puppy, you're just empty and void inside. So what we can do here is, where to go, is we can turn one of these into a default value, right? So let's just say this. Not good at Call of Duty. And it says positional parameters must be enclosed in square brackets here. So what did we screw up here? That's a good question. What did we screw up here? This thinks it's optional here. Let's try that. Brian Cairns. Now if we omit this guy here, we suddenly get Brian not good at Call of Duty. So what we're doing here is we are saying this will be null. We are not assigning a value to it. It must be assigned, and there it is here. So if we just delete this, you notice how suddenly it's going to freak out and say 1 argument is required but 0 found, because this is the required argument. We haven't supplied anything, and you can't actually do anything with it. So you could actually pass null, which may actually make this thing explode. Let's find out. Yep, see, the method blah, blah, blah was called on null. So we're saying null plus these strings. So Brian, well, let's just change this to is not, because I'm really not good at Call of Duty. I've been trying to get better at it, but I'm not good at it. Let's run this again. So we've supplied the first value, and it's not null. And then we have this optional, and we are assigning the value to it. So because it's optional, and you have to include any optionals in these brackets, you don't need it. You see how there's no name here. But the minute we include it, and let's just do my name again just because why not? Run this, then suddenly it is not using the optional parameter because we have supplied the value. Once this value is in here, it gets converted to a variable, and it replaces this. So think of this right here as like a temporary variable. And let's say, oops, let's just call this string extra. let's make that lowercase just because I'm kind of snobby about that these days. And we're going to add the extra in there. So you can see how we actually can do this, right? So we have Brian, which we've supplied, Karen's, which we've supplied. We did not supply the extra, therefore it's going to use the default. And we could actually take this out right here, and you'll get two of them. See how that works? So as you can see, functions are pretty neat. There's a lot of things you can do with them. One thing you should really be aware of when you're creating your functions, though, is the actual scope of the variable, because sometimes things can get a little squirrely and you're looking at one function, and because you've named the variable the same in many functions, you think that variable goes everywhere, and it really doesn't. So that's all for this tutorial. I'm going to keep going down. There's actually a lot to cover on functions, so we're going to make a couple of these. But if you found this helpful or even moderately entertaining, go ahead and visit voidrooms.com for the source code for this and all other tutorials. And if you're so inclined, go out and join the Voidrooms Facebook group. There are 1,720 members out there right now, all walks of life, all programming languages. So definitely check that out. Join up, become a member, and help everybody else out. Thanks for watching. Hey everybody, this is Brian, and welcome to the 6th tutorial on Flutter. We're going to continue down our path with Dart. I'm going to try and go through these fairly quickly, but because Dart is a new language and there's new features, we got to go through some of this elementary stuff. So some of you more advanced folks, just bear with me while I slog through this. There are some new features, so definitely pay attention, and I'll try to call them out when I get there. So this is going to be our advanced functions tutorial. So the first thing we're going to do is just create a new project here. Make sure it's Dart console application. And let's call this Advanced Func. Why not? I have a really hard time coming up with names for this sort of stuff. And it'll process and do its thing. Tick tock, IntelliJ's always so slow. There we go. All right, so we've covered some of this stuff before. We've got our calculate function, which is off in the lib, and we're going to actually use that this tutorial. So if you're curious about how that works, definitely pay attention. All right, so we're going to go ahead and just get rid of this. We're going to leave this up here this time. And we're going to cover that in just a second, but let's get through the rest of this first. So in our main function, we want to make a variable. And let's just say list. My keyboard's crooked. Bear with me here. This is what happens when you get old and cranky. So we're going to make a list with an integer type. Call it list. And if you remember, these little brackets with the type in it is generic programming, because that list can hold more than one type. And then in our list, we're just going to add a few values. So we'll say 1. And I'm not going to really add too many variables. I'm actually just going to use this one variable, because this is a function tutorial, and I don't really want to spend a lot of time wasting your time writing variables. So I know a lot of tutorials out there have like these big, weird, complex algorithms that are hard to understand. We're not doing that. All right, so we've got our variable that we're going to work with. So the first thing we're going to cover is a function as an object. Maybe if I can spell object. So what does that really mean? Let's just make our function here. Nothing super special about this, right? And we're just going to say print I. There's really nothing going on in there. If you remember, everything in Dart is an object, and I mean everything, right down to functions. So we're going to say list for each. Now, you notice how there's a little bit of verbiage here. For each, and then there's parentheses, int, and then an arrow, and then void something something. We're just going to double click it from the moment, and you see how it says void f element, e element, sorry. So really what that's saying is it cannot return anything, void, and the function itself is going to take the element. Now the element goes back to generic programming. Under the hood, this actually says something like this. List E, and E would be the representation of whatever object we're shoving in there. So the template for this thing has to be void, cannot return something, and then it has to take the element. So we're just going to say as object. Finish this off with our semicolon here. And let's actually, because we're going to make a bunch of these. I just finished watching Stranger Things last night. Oh my God, that show is so good. But now I'm trying to find other things to watch, like a Netflix junkie. All right, so when we run this, this is what happens. It says as an object, bam, and then list for each, and then we're calling the actual function as an object itself. This object is instigated when the code is run, so we don't have to do this, new blah blah blah. It already exists in memory, and there's one copy of it. So as object, and then that has to follow the template. So if we do something like this, it may get kind of franky on us and say, hey, nope, yep, see, argument int string void cannot be assigned, blah 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 blah. Basically what that's saying is it has to follow the template, and the template is you're passing one element which is in that list. So that is a function as an object. I tend to not use that too much because then the code gets kind of weird. You're trying to hunt down this thing and figure out what's going on. But if you just want to go through it, then I guess it's okay. What I tend to do is, I'm just going to copy and paste this whole thing rather than type that all out. Bang. As an anonymous function. I'm lazy. I really didn't want to spell anonymous like 6 times. This keyboard's kind of jacking with me. I need a new one. I was playing Call of Duty, and admittedly, I slammed my fist down on the keyboard, and now it's acting kind of crazy. So, anyways, so we're going to do for each. Now, this time, we're going to do something a little different. We're going to do what's called an anonymous function. Now, an anonymous function has kind of a crazy syntax, but it'll save you a lot of headache. What you can do is say for each, and then we're going to just say parentheses, I, and then bracket, and don't forget to close this out with a semicolon, and we're just going to say print I. This is bananas. What is this? Let's run this, make sure this actually works. So as an anonymous function, bang. What in the heck is going on here? So what we're really doing is we're creating a function in memory that only exists in this little loop here. It actually under the hood gets optimized and it turns into a temporary function in the base code or whatever, but for our purposes we don't have to jump around all over the place. We just know that, hey, we want to do this and we want to do it right here. So it does the exact same thing as this. It's just you don't have an independent function that you can call as an object. Notice the syntax is we have our parameters, and then we have our brackets, so we have our scope block here, and then we have our actual code of what we're going to run. It's pretty simple, pretty elegant. I actually hated anonymous functions when I first saw them, but I think I first saw them in Java, and they just drove me nuts. But they're pretty useful. As you can see, you don't have to make yet a separate function. Now, if you're going to call this many, many times, like over the course of your entire program, then definitely branch it off into a first-class function right here. So now we're going to see what I mean about my keyboard? External. Why can you not spell keyboard? I'm going to Best Buy and getting a new one. Forget this. External function. So what is an external function? We've been talking about this little file over here for a while now. Let's crack this back open. You see how it's got a function. It returns an integer, and it's called calculate. And it has no parameters, and then it just returns 6 times 7. We can actually call that externally. So let's just say print. And how do we know what to do? I mean, how do we call that thing? Can we just say calculate? Notice how when you start typing calculate, it recommends advfunc.calc. Where did it get that name from? Let's just double click it so it puts it in there for us. It actually got it up here from this import statement that we left. And if you accidentally delete it, go ahead and retype all that in. But it's very simple. Import, and then we're importing a package, semicolon, and then the path to that package. advfunc is actually the name of our project here, advfunc. And then the actual Dart file, advfunc.dart down here as, and this is where we're creating the variable. So really, it's that. And we can run this. And you can see the result of that is 42. So let's crack this open. Let's just add another one here. Let's say bool loves this keyboard. String name. So if the person in this function is Brian, me, then I do not love my keyboard. Otherwise, we're going to return true. Because everybody else in the world loves their keyboard. Especially when they're playing Call of Duty, little bastards. Alright, so as you can see, whoops, loves this keyboard. And then we could say I'm so buying a new keyboard. And there's our false. So how would you actually, go about making your own here? You can actually make a new one. We'll just call this Dart file, and let's call this my file. .dart. And rather than typing that out again, we're just going to cut this, put it in our little file. Notice how when we did that, suddenly main.dart got cranky because this no longer exists. So now we got to make another import. We're importing a package. And there's different types of imports, but we're just going to cover a package for today. And notice how it actually tries to help you out. So we're going to import advfunc/myfile.dart, the file we just created. Now we need to make it as a variable, and let's call this Call of Duty. It is currently grayed out because it's unused. We're going to actually change that. Bang, now suddenly it's used. Does the same thing. So that is how you would import an external function. Now, the next one is going to get a little bit crazy, but this is the last one in our little tutorial here. We're going to compare apples to oranges. You've heard that expression before if you're in the United States, or maybe even if you're out of the United States. So we're going to make optional parameters here, and we're going to say int apples equals 0 and int oranges equals 0. And then we're just going to simply say compare to other number and actually we don't have to do any of that, we can just return it. I had different in my little notes here how I did it, but this actually, there we go. Maybe. There we go. That didn't work either. What did I do wrong here? Return type int. Oh, that's why, because it's doing an int type. Yeah. So the compare to function is something I really didn't want to use, but basically, let's just switch this just so we can see. Compare to is used for ordering in lists, which we'll cover in a future tutorial, but let's just do this. What we're really focusing on is this part right here. We have our function, and all this does is it has optional parameters. Notice these are optional. They're optional because they're within these brackets and they have a default value. And we're just going to say, man, are you possessed, keyboard? What are you doing here? Jeez. All right, so naming a parameter, and we're going to just say print compare. Notice how you can actually put the parameter name in there. And then hit enter. And it's giving us a -1 because they're not. So let's just change this to 9 and that to 3. You see how it's now a 1 because it does an ordering thing. I was going to use a bool, but let's just say this is 6 and this is 6, and it should come back as 0, meaning they are equal. So why would you want to actually name your parameter? Why can't you just, do the order here? Very simple. A lot of more advanced code will actually use name parameters. When you get into Flutter, you'll actually use them quite a bit. And it's just an elegant way of saying, hey, this is actually going to be this. And I just want to test this. I want to actually move this around. So you notice how we've actually got it backwards. In the compare statement, it's apples, then oranges, but we're actually saying oranges, then apples. This would normally throw an error in other languages, but should run just fine, and it does. So that is also why you would use it if you don't want to use an ordered list or an ordered list of parameters. So more information, go out and read the official documentation in optional parameters, and you can see how when calling a function you can specify name parameters, etc., etc. Definitely read up their documentation. It's well worth the read. I know it's a little bit lengthy, but I can't possibly cover everything in these videos. If you found this educational entertaining, the source code will be out on the website. You can just click for the link out to GitHub. And there is a Void Rooms Facebook group with, I think, 1,700 other programmers out there, all walks of life. We can definitely help you out with any issues you come up with. Unfortunately, I get just an extreme amount of email. I've actually had to make a separate account and hide it from the world just as I couldn't do anything with it. So don't email me. Go out to the Void Rooms Facebook group and go out to GitHub and get the code. I'll talk to you guys later. Thanks. Hey everybody, this is Brian and welcome to the 7th Dart tutorial. Alright, so today we're going to click language and then go back to tour. And what we're going to start today is called classes. You may be sitting in a class watching this video, but this is different. So first off, what is a class? If you've never come from any other language, it'll say Dart is an object-oriented language with classes and mixin-based inheritance. What in the heck does that mean? What it really means is a class is a blueprint. From that blueprint, you create an instance of that object. So let's say you have a house. Well, a house is a abstract concept, right? There's different types of houses that come in all sizes, shapes, colors, rooms, locations. So a house would be your blueprint. From that, you would instigate or make instances of houses. So you would actually build the houses from those blueprints. And that's kind of what we're going to be doing today. All right, so we're going to create a new project here. And we're going to make sure it's console application in Dart. And let's call this classes 1, even though it's really like intro to classes. So while that is just grinding away, calculating the trajectory of everything in the universe, what does the mixin-based inheritance mean? You'll see this passed around quite a bit. Really what that means is you can have multiple classes and have those classes inherit from each other. For example, you are inherited from your mother and your father. So let's say your mother has red hair and your father has blue eyes. You probably have red hair and blue eyes. Actually, I think most redheads have blue eyes anyways. When I had hair, I was a redhead. But anyways, so let's just dive right in here. So first thing I want to cover is why do we need classes to begin with? We can already put functions in here. So let's just say we want to do void print speak. Whoops. That was just stupid. We want to speak. And then in here we're going to print something, right? And we can call this pretty much from wherever we want, right? We've done this before. And we're going to say, so when we run this, we know absolutely what to expect. It's speaking. But let's say we want to mimic a dog or a cat. Then we've got to change this. So let's say string, I don't know what to call this, noise. And then we're going to add the noise here. And oops, yep, we forgot to add this. So now we want to say, we're going to just imitate a cat here. Meow, why not? And now it's going to meow. But what if we want to do a dog now? Well, okay, I guess we could just do this and then bark instead. But we are now imitating a dog and a cat, but we don't actually have a dog and a cat. What if we want to add things like fur color, eye color, name, things like that? That's where classes really shine. So first thing we're going to do is make a new Dart file. Let's just call it cat.dart. And notice how I put it in the bin file. If you read the official documentation, the lib is actually really for external or public things. So if you want to share that with the rest of the world, where bin is really for your internal program. I may be wrong on that, but that's what I read. And whoops, we don't say void, we say class because we're giving it an actual type. Now this is not a return type, this is a declaration. Notice how it doesn't take any parentheses. It just has these brackets. So there's no parameters here. We will get into that. They're called constructors. We'll get into that into a future tutorial. But right now we're going to keep it simple here. So now we're going to say void speak print meow. And we're going to just, through the magic of copy and paste, make a new file. Call this dog. And go back to our main file here. Let's just get rid of these. First thing we really need to do is actually import those. So we're going to import, and we're going to import cat.dart, and we're going to import dog.dart. Thought my phone made a weird noise. I just heard that. Anyways, I dropped my phone and it, like, the camera case cracked. The phone itself is fine, but I had to order a special part, but now the phone's acting just weird. Alright, so now that we have our classes, our blueprints, we have to actually make instances of those objects. So we're going to say cat, and I don't know what to call the cat. Let's call him Mr. Twinkles. I have no idea what to name the cat. Equal new cat. So what are we doing here? We've seen something similar. So we're declaring a type, which is actually our class, our blueprint, this guy right here. And then we're saying our variable name, and then we're going to actually assign it a value. We're saying new. New is a keyword. New cat, meaning we're going to take that cat blueprint, make a brand new version of that, and hand it to this variable. We could also do this. So now we have two instances of the same blueprint, but they're two different objects. We have an object here and an object here. And we can say now we have an instance of our dog class. And then we can say Mr. Twinkles, speak, Fluffy, speak, and we'll say, what do we call him? Fido, speak. I prefer to do lowercase, but we should, because they're names, I'm kind of weird about that sometimes. So when we run this bad boy, you'll see we have meow meow barks. We've got both cats meowing and dog barking here, so we got a noisy room. Okay, great. But what are we really leveraging here? What's the real power of classes? What we can do here is say like bool clause out, and with the dog we can say string color So what we have now is our blueprints are different, right? Both of them have a speak, but dog has a color, cat has a claws out. And we can access those through the properties. So let's say Fido, oops, not final, Fido, there we go. And let's just print this bad boy. My spelling skills are much to be desired today. There we go. So you can see we now have brown after bark because we're printing out Fido's color. So that is, in a nutshell, how you would build a class and how you would actually make your blueprint. Now, there's a lot that goes into this. We're going to have to split this up over several videos. And what I want to do now is actually make a bit more of a complex example. And to do that, we're going to kind of abandon the dog-cat example. We're going to make a new file, and we're going to call it, let's call it house. And in here, we're going to say class house, and we're going to make our scope. Now, we're going to make a private variable here. We're going to say age. And then we're going to make a public variable. Whoops. And then we're just going to make a couple properties that are public here. Like we're going to say int width, int height. Ah, that was my phone. I did hear it. Go away, phone. I'm doing a tutorial. And then what is the difference between private and public? Some of you who know other languages understand this, but some of you that are new may not. Notice how it has this underscore in the beginning of it. That is how you differentiate between private and public. Private means that only this class inside of this scope can access this variable. Public means anything in the class and outside of it can access it. So, good example. Let's just import here. We're just going to say house1 equal new house. So if we try to say house1 dot, and we do that underscore age equal 99 years old, you notice how it is not liking that. It's going to say the setter age is undefined in class house. What does that mean? The setter age. That makes literally no sense. What's going on here? So let's try house1 dot width equal, we'll say this is 100 feet, and house1 dot height, actually we should have called that length, but actually let's change that because I want this to actually make sense. And let's say this is 200 feet long. That's kind of a big house. Those take it just fine. So what is this complaining about? Let's just try to run it. And of course, boom, same error. Class house has no instance setter underscore age. It's doing that because we have a scope issue. This is a private variable and we're trying to access it outside of the class. Now, if we're in the class itself, and let's just say notice how it suddenly works. That is called scope within the class. You cannot access that outside of this class or this scope. Whenever you see these brackets, think of scope, because it is private. Private is denoted by that underscore. That is specific to this language, so definitely pay attention to that. In most other languages, you actually write the word public or private in front of the type. Dart goes away from that whole concept, but fear not. There is an easy way to set that, and we're going to show that right now. What we're going to do is a getter and setter. So we're going to say, you remember the error message that it popped out with is there is no setter. What's a setter? Well, this is a concept that sprung up about, I want to say 20 some odd years ago. And we're just going to go over it real quick. So when we get something, you're taking something, right? You're saying, give it to me. So we're going to get, And we're going to say footage. And then we're going to do fat arrow width times length. What have we done here? We're getting a getter. We're creating a getter using the get keyword that is an integer type. The variable is called footage. The fat arrow really basically says we're making an anonymous function here. Because it's all one line, we don't have to break this into like something like this. Int footage return width times length. Yeah, you don't have to do something like that. So we're just going to delete that because it's all one line, right? It's all compact. You can definitely do it the other way, but that's what all this fat arrow really does. It just condenses it to one line. So we're getting that. And we have this anonymous function here. Or is it inline function? Anonymous versus inline. That always messes me up. So let's get our square footage from this thing. Let's actually delete that so it'll run. And we're going to say print house one, oops, footage. So when we run this, you can see this is a large house. Let's scale that down. That's like, massive house. Let's just say this is a length of 50 feet. Actually, 25 feet by 60-foot house. Okay, that's more reasonable. That's about a normal house size here. So how is it calculating? How's it getting this footage? Well, back to our blueprint here. We got our getter. And the getter is saying, hey, whenever you try to access this variable, run this code. And all that's doing is taking our variables, width and length, and multiplying them, and then returning them. Pretty simple. But what if we want to actually set something? We want to set the age of the house up here. So let's do that. Now, we have another problem is we can't access that because it's a private variable. That's where getters and setters work in tandem. So we're going to say int get, and let's just call this home age. That way, no, let's call this years. That way there's no real issue between underscore age and age. And we're going to say return age, and then we're going to set years old value. I want to give it a type there. So what we're really doing is we're saying, okay, when you try to get something out of this, when you're trying to access that, return this, which is actually up here, this private variable. However, when you're trying to set it or save something to, think of a variable as a container, like a little bucket. Remember, a variable is something that will change. The contents of that bucket will change. So when we go to pull something out of that bucket, we're calling get. When we go to put something into the bucket, we're calling set. Think of it in terms of those concepts and it'll make much more sense. Now set and get, you have to have a type here. So we want to pull out of that bucket an integer. And set, we want to put into that bucket an integer. And that's how we're actually doing that. So when we go to pull out of the bucket, this will get run. When we go to put into the bucket, this will get run. That's a very confusing concept if you're new to programming. That's why I kind of really wanted to cover it. So we're going to say house one dot years old equal, let's say it's a 10-year-old house, and then we're going to print house one dot years old. Let's run this, and you can see there's our 10. So here we're calling the setter. Here we're calling the getter. Getters and setters are important because sometimes you don't want to actually expose your variable to the outside world, or you want to control how it's accessed. For example, let's say you want to set this, but yeah, you're running a real estate agency and older houses really are more attractive. So you want to add 10 years to that house. So what we're doing here is a little sneaky, right? Because we're saying house 1 years old is 10, but under the hood, in the background, we're actually adding 10 years. So it's now 20 years old. So always think of getters and setters as if you're working with a bucket, and it'll be much easier in your head. And that's why you need to use them, so you can actually isolate that variable from the outside world. So that's great and all. What happens if we have multiple homes here? So let's just make a new house. Let's make a couple of them. And let's add a property in here called, oh, we've already got it, color. And we're going to go back here and we're going to say I want a red house. House2.color. I want a blue house. Then house 3. I need a good color. I need like a solid color that's just going to stand out. Black. You don't see any black houses. I don't know why. Black's a pretty cool color. I think it'd be really trendy to have like a completely black house. I'd buy one. So, back to our trusty list example with generics programming. Remember how we have worked with, I think, strings and integers in the past. See how it says list, and then the little arrows, and then E? That is the template we're going to be working with. And we are going to say we want to use our house class. Notice how, maybe it's not visible, it's got that little C right here. It wasn't too visible when I'm on it, but it's got that C. That denotes it's a class. So we're going to use the class, not an actual variable. So we're going to call this homes equal new list house. Now that statement that we've worked in the past makes a little more sense because we know now that list is actually under the hood a class. And this just means it's using generic programming, which we will use in future tutorials. Now we're just going to say homes.forEach, and in here we're going to say, whoopsie, come on keyboard, work with me here, there we go. We are just going to do our function. I'm going to say value, and we're going to say print value.color. So really what we're doing here is we're saying make a list, and in that list we're going to store homes, or the house class, that blueprint. And for each of them we're going to print out the color. And you can see how it is now, where'd it go? Why did it not do that? There's brown. Print value.color. Did I screw that up? You know it's been a very long day when you just completely forget to do something. There's nothing in our list. That's why it wasn't working. My brain is totally fried. I have bought a house. I am currently doing a lot of stuff at work, so bear with me if I'm a little scatterbrained sometimes. Home ownership will definitely make you lose your mind. I spent all weekend installing these lights. It should have been the easiest thing in the world. After about 1 million cuss words, the lights are installed and working though. There we go. So there's our 3 houses with the 3 different colors. And in there you can access the other properties and things too, like, footage. Things like that. Alright, so that is, in a nutshell, intro to classes. I hope you found this educational and entertaining. We're going to cover these a little more in depth. Be sure to really read up on classes on the official Dart site. And for the source code, go out to my website, voidrums.com, click tutorials, and there's a link to my GitHub repos. I do have it out here as Flutter tutorials, and then I have them as submodules in here, and I'll put in the additional submodules. If you're so inclined, if this helped you, definitely consider donating. This site's run 100% off your donations, and I thank you for watching. Hey everybody, this is Brian and welcome to the 8th tutorial on Flutter and Dart. We're going to go ahead and continue our conversation on classes. Well, let's actually call this class 2. Well, let's call it classes 2. There we go. And while that's churning away, we're going to look at what we're going to cover today is called constructors. What are constructors? Well, whenever you have a class and you create a new instance of it, something has to happen in the background, and that's what we're going to cover today. That background is called a constructor. It's when the object is actually constructed in memory. And to kind of solidify that main point here, what we're going to do is we're going to go out here and we're going to say new house dart. And I'm kind of doing this unscripted, meaning I do not have my notes. I'm just kind of typing. So there'll probably be some errors and maybe some goof ups. And we're going to keep this class very simple because we're not focused on the class itself, but rather the constructor. So width equals 0 and length. All right, so we've got that, and we need to import house.dart. And we're going to say house1 equal new house. So we've done this before. We know what this is. It's just going to make a new house. What's going on under the hood here is it's looking at your blueprint and saying, what do I need to do? And then it's going out and making a new instance of this. And hold on, let me turn my music down. I can't even hear myself think here. I have to keep music on the background or my headset shuts off. It's kind of like an annoying feature. But anyways, so it's saying, what do I need to do here? Now, it knows what it needs to do by way of what's called a constructor. And every class has what's called a default constructor, meaning it just magically exists. And if you're wondering where it is, it's right here. Boom. So somewhere in there, under the hood, unknown to you, is a function that looks like this. And it probably just says return, would be my guess. Now, all that is, it's called the default constructor, but it doesn't exist in a manner that you can see it. It's under the hood, and you'll never access it. It exists solely for the compiler. Now, if you want to actually play around with it, you can add it in. Constructed. So what happens now is when we run this, you'll see it suddenly says, boom, constructed. Where's that getting called? We haven't changed anything in our main. So it's saying, all right, here's the blueprint we want to use. Here's the name of the variable we want to use. Make a new instance of that and use this constructor. In this case, it's saying use the default constructor. You can tell it's a default because there is a parentheses with nothing in it. That's called the default constructor. To solidify that, we're going to make yet another one. And it's going to say default constructor already defined, meaning it knows that's the default because it's just an empty set of parentheses. Okay, that's great. What do you need a constructor for? What's the whole purpose of this thing? Constructor says, hey, what if you want to initialize a set of variables before you actually use them? In this case, let's say we want to use the width and the length. We don't want those to be 0. So whenever a new house is created, we want to automatically set those variables. And we want to force whoever is using this class to set those variables. So we're going to say int w, int l, and we are going to say width equal w, length equal l. And we're going to print these out. Yeah, fat fingered that one. All right, so when we go to run this now, you guessed it, it's going to crash. Bang. Why? No constructor house with matching arguments declared in class home. Whenever you see that, your first thing should be look for the new keyword, and then you'll see the error right next to it. It says 2 required arguments, but 0 found. Well, how do we know what those arguments are? By looking at the constructor. We have 2 integers we have to deal with here. So let's say we want it to be 5 by 9. Bang. So now suddenly we have a width of 5 and a length of 9. We can actually take that a step further and make this, you guessed it, optional. And let's say this is 5. Let's say this is 9. Well, let's go back to our program here and notice how we've got to actually name them out now. I'm doing this for illustrative purposes. And we want to say we want the width to actually be 6 instead of 5. And it should be 6 by 9. There we go. So that, in a nutshell, is how to deal with a constructor and why you need one. Now, special note, Dart does not have, at least I haven't found, the concept of a deconstructor. And what a deconstructor is when the class is actually being destroyed. Under the hood, there's this thing called garbage collection. And garbage collection is a very complex topic, but it's very easy to understand. When you are creating variables, right here, the use of the new keyword, you are putting that out on memory, and you're putting it on something called the heap. Under the hood, it may actually be somewhere else, but the heap is just a giant free store memory. Think of it like a giant warehouse. You're basically opening the door of the warehouse and throwing a house in it and saying, here, store this somewhere, I don't care where. The problem is, when your program dies or gets shut off or the user closes it or whatever, that house still sits out in memory. So you need to actually delete that. Garbage collection takes care of all that mess for you. All you have to do is say, I want a new house and I want you to put it somewhere, I don't care where, and let me access it when I need it. And then when your program is closed, or if that variable goes out of scope, let's say we have a function up here. Let's move this up here. Whoops. Yeah. And let's call a test. Does the same thing. However, something drastically different is happening in the background here. What we're going to say, and I'm just going to put it in comments here. And then flagged for garbage collection. That's what's really going on in the background here. So when this test function is called, it's going to go up and it's going to say create a new house. Bang. Then it's going to call our constructor, whatever the constructor may be. Then in the background, it goes out of scope. What happens is everything that was created in this scope is now flagged for garbage collection. What that means is it is no longer being used by the program, and the program thinks it's safe to delete it out of memory. Now, if you've ever worked with older languages like C and C++, if you try to access something that doesn't actually exist in memory, your whole program just goes kaboom and crashes. Garbage collection takes all that headache away, meaning you don't have to worry about it. You just have to create it, it'll take care of it, and then when you're no longer using it anymore, it'll get rid of it for you. If your program crashes and dies an ugly death, it'll delete all that memory for you and you don't have to worry about it. Whew. So why does all this matter to you? Because all of this is being done under the hood. Now, there's a special case. What if, and just follow me here, you want to actually do something with this and then close it out? You really should, and there's probably a million other ways to do this, dispose your class, meaning, and this is very similar, it's actually built in, I think, in some other languages. Kill me now. You would call that before the end here. So you would say you may be tempted to do something like that. Now, why would you do this? Let's say you opened a file or a database or a network connection. You would want to actually close it here. So you would say close all open connections or close all the things. That would be a good way to do it. But remember, under the hood, garbage collection is being called. So if you forget to do any of this, it's going to happen automatically, and you don't have to worry about it. That's a very nice concept. There are more advanced topics to it, but that in a nutshell is constructors and deconstructors. I hope you found this educational and entertaining, and thank you for watching. If you're so inclined, you can get the source code for this and other tutorials out on my website. Just go out to tutorials, click on the tutorials link, and go out to GitHub, and I will have all the code out there. Thank you. Hey everybody, this is Brian. Welcome to the drumroll. Where are we? We are on the 9th Flutter tutorial. We're going to continue our conversation on classes here. Did have some interesting feedback from this guy here, President 1. Dart is dead. Why are you doing tuts on this? I actually don't think Dart is dead. I think Dart's actually just getting started. I think it's very new and very in its infancy. And I'm hoping Google grows it quite a bit. So that is why, kind sir, I am doing tutorials on this. So we're going to continue our conversation about classes. If you're trying to follow along with the official documentation, we are on extending a class. So extending a class, use extends to create a subclass and super to refer to the superclass. What in the heck does that mean? Well, we're going to cover that over the next 3 tutorials. And I'm going to do a little bit here. I'm going to actually cover how to extend a class, abstract classes, and mix-ins. But we're going to have to kind of break it up to a few tutorials. So let's just get going with this one here. And let's do next. Gotta adjust my office chair here. What's up with that? And while that is calculating the meaning of life to everything, I'm going to actually adjust this chair. Man, it's like driving me nuts. All right, so what we're going to look at here is classes and inheritance. And you may have heard of inheritance before in other languages. So the first thing we're going to do here is we're going to make a new Dart file. We'll call it mammal. And in mammal, we're going to make a class. And we're going to say bool has backbone. And we're going to make another bool has hair, because a mammal has to have a backbone and hair. And there is our beautiful mammal class in all of its glory. So what we want to do now is actually make another one. And we're going to call this feline. For all you cat lovers out there, we're going to import the mammal class. And we're going to say class feline. And this is where the extends keyword comes in. Extends mammal. So what have we actually done here? If you're not familiar at all with inheritance and what I'm talking about here, is we're extending this class. It used to be, the keyword used to be in other languages inherit, or it was just a semicolon. So what we're doing is we're taking the mammal class and actually adding to it or extending it. So we're going to say bool has clause. True, because most cats have claws. And then we're just going to make this void test. We're going to say assert. And you notice how IntelliSense is smart enough to know what's going on here. Has claws, has backbone, has hair. So you can see the other properties here. So we're just going to assert that this has a backbone. And we're going to assert that it has hair. Now what assert does is it actually throws an error message if this tries anything and it doesn't evaluate to true. So that's just a test function we're going to leave in there for now. But what we're going to do is take this even further and show you that you can do some really cool things with inheritance here. So now we're going to take our feline class that we made. We're going to make a class, we'll call it lion. And we're going to say void roar. And let's just do this. So tomorrow is Thanksgiving while I'm typing here. And I'm actually kind of nervous because I'm cooking a turkey for the first time. Yeah, it's going to be interesting here. Some people have told me to cook the turkey upside down. Some people have told me to not stuff it. Some people have told me to stuff it. Some people have told me to do all of these crazy things. One person told me to get like a surgical syringe and actually inject things into it. I'm guessing that's how you actually like calm down your guests. You just like inject like some sort of sedative into the turkey. All right, so what we're doing here is we've got our test, and we've got our roar function. Now let's actually just test this whole thing out. Let's get rid of this. And let's say lion, Simba, why not? Is that actually how you spell Simba? Oh well. Equal new lion. And we're going to say Simba dot, and you notice how, bam, it has all these other properties here. So we can actually call test. We can actually make him roar, although I don't think Simba would roar, but come on, keyboard, you can do it. I believe in you. And he's roaring, and the test ran. We can actually go back here, and this is a tricky thing about inheritance. Let's say back in the mammal class here, we flip this to false. Then we're going to say not all mammals have hair because I'm changing everything. Well, you can see how feline's test is now going to just explode. Lion's test is now just going to explode. So let's run this and see what happens. And you can see unhandled exemption, failed assertion, meaning our assert statement evaluated to false, has hair is not true. And it's saying line 7, number 12. So there's 712, bam, that's where our issue is, right here. And then we can kind of do this, and you can see how it's in lion test, da 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 da. What we can actually try here is play around with what's called the super class, and we can say super, whoops, dot test. So what is this actually doing? Super actually grabs the class that you're extending, in this case feline, and it's going to call test here in feline. So let's actually do this, print testing in feline. And let's do this. Print testing in lion. That way we know exactly where this is coming from here. And you can see how it's testing in lion, testing in feline, because this is being called, but then we're calling super.test, which is actually calling in feline. Now, this assert function is actually failing right here. It's saying blah, 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 line 9, 12 is not true. And we can see how it's calling feline test right here. And it gives you the path to the file. And I think, yep, you can actually click on it. It takes you right to it. So you can follow, this is called a trail here, if you will, or a stack trace. You can see that it's being called here, it's being called here, and finally, boom, that's where the error is being called. So that is the tricky part about inheritance, is if you make something and other people inherit classes and extend them, you can really break a lot of things. And so you have to be a little careful, and you have to almost not trust what you're extending. And that is where overrides come in, right? So we should just put override there so we know what we're doing here. This is just a declaration telling us that we're overriding this. What we could actually do is we could actually put a setter in here and set that to true. But I'm not going to mess around with it. I want to leave this as is so you understand some of the pitfalls that can happen when you're doing inheritance. So to kind of recap here, we have our lion class. The lion inherits from feline. Feline actually inherits from mammal. And let's flip this back to true. That way if somebody downloads the code, it's not going to have an error and I don't get 100 hate mails. So what is mammal really doing here? Mammal is considered the root superclass, if you will, meaning it's not extending anything else. It's just the base class, if you will. All of these properties then flow up through all of the other things that are inheriting it. So that is inheritance in a nutshell. Short, simple, to the point, but a very powerful feature. You can do a lot of cool things with this, but you can also paint yourself into a corner. So definitely structure your programs well. That's it. Thank you for watching. I hope you found this educational and entertaining. If you're looking for the source code for this and other tutorials, go out to my website, voidrealms.com. You can go out to GitHub and download all the source. Also, there is a VoidRealms Facebook group with 1,700 other programmers out there that can definitely help you if you have any issues. Hey everybody, this is Brian. Welcome to the, what are we on, the 10th Flutter tutorial. We're going to talk about abstraction today. So, what is an abstract class? Use the abstract modifier to define an abstract class, a class that can't be instanated, meaning you can't make an instance of it. Abstract classes are useful for defining interfaces. What is that? What are we talking about here? So there's a few key concepts we have to understand. First, an abstract class cannot be created. You can't use the new keyword. Second, we're going to be defining something called an interface. An interface, just think of that simply as a contract. So when we look at, this is the previous tutorial, we had the mammal class, which has backbone, has hair, and we're setting the value actually in the mammal class. The problem with that is when we change something down here, it blew up the entire stack. So if we changed it here, suddenly feline stopped working, lion stopped working. We're going to fix all that today. So let's just go new project. We're going to make a new Dart console application. We're going to call this classes 4. Yes, let's do this window. And that will calculate the meaning of life and everything else. All right, so let's just get that out of there. Somebody emailed me and said, hey, stop complaining about how slow that is. Mine's really slow. So we're going to make a new, you guessed it, mammal file. And we're going to say abstract class. And we're going to say bool has backbone. Oops. I've got weekend on the brain. It's technically my Friday. It's the day before Thanksgiving. I'm just kind of cranking out a couple tutorials here. And avoid speak. So, what is going on here? This looks like a normal class, but there's a few minor changes. The abstract puts the abstraction to this class, and then we have some elements here that don't have a value. That's actually part of our interface. What we're saying is anything that inherits this class has to include these. Think of an interface as a contract. It's a lot like buying a car. So let's go out and say feline. My office chair is driving me nuts. Sorry about that. Mammal. And we're going to say abstract class feline. Whoops. Extends mammal. So far, nothing's really changed here, right? Bool has claws. Let's play around with this and see what happens. Let's actually go out to our main, and we're going to import that feline class here. We're going to say feline, call it cat equal new feline, and uh-oh, we already have a problem. As you have suspected, abstract classes cannot be created with the new expression. We can't instantiate them. Can't make a new instance of it. So how do we actually do that? Well, we have to make a concrete class here. So let's actually go file new. We're going to make a lion class here because why not? Whoops, lost my place in my notes here. All right, so in our lion class, we're going to actually import the feline. And then we're going to say class lion extends feline. Whoops, that is not what I wanted. There we go. Now it's giving us some sort of other issue. It's saying, okay, Missing concrete implementations. Because this is a concrete class, not an abstract class, we have to actually now implement that interface, or actually interfaces, because this is an inherited interface. So when we mouse over here, you can see that it has claws, has backbone, has hair. So it's missing the implementations from feline and mammal. And you can actually right click on this, go to generate, and then implement methods, and you can see exactly what it's missing and what it's from. You can even double click and create it, which I'm not a big fan of because I don't like the way it does it. But if you're curious, it just looks like that. So we're going to say bool has backbone, and we're going to actually implement this now. Bool has hair. Bool has claws. Misspelled has twice. Wow. So we have everything that we need now. We can actually make an instance of this thing. So let's change this. We can now actually make an instance of this thing, and we can actually .speak and see what we want it to do. Now, I've never heard a lion say hello world, so we're going to change that a little bit here. We're going to go in here and we're going to say we're going to make the lion roar instead. So you can see how it's very similar to actually just inheriting and extending a class, but there's some key caveats here. First off, you're not setting this value in the abstract class. You're not setting the actual getter. So that's called an interface. You actually have to have that in your concrete class. Without it, it will actually generate an error. See how suddenly it's complaining, missing concrete implementation of mammal.hasBackbone. You would do that for certain things. For example, if you're building a car or a truck, not all cars have all the same features, but you want certain things that make up a car. Car has 4 wheels, for example. Car has a windshield most of the time. If you pay extra, usually it has a windshield. So the other key component here that we're missing is you can actually do some really cool things with abstraction and interfaces. So we're going to actually make another file here and call it a bird. And we're going to say abstract class bird. And we're going to say bool has wings. Now let's just get a little crazy here. Let's make another one. Scorpion. I don't know what that thing's called on the back of a scorpion. I just call it a stinger. Why not? So what are we doing here? We're just making abstract classes. We're actually making interfaces. So we're going to make a concrete class now, and we're going to call it monster. We're going to actually build a monster here because that's just how cool we are. We have nothing better to do. We're going to build a monster. So we're going to make our bird, or we're going to import our bird. We're going to import the scorpion. And we're going to actually import the feline. And this is an example of interfaces. So I'm just going to put that in case anybody's wondering. So we're going to say class monster implements. And we're going to say bird, feline, and scorpion. So now we've got multiple inheritance going on here. But as you can tell, we also have multiple things that we're going to have to make concrete implementations of. So we're going to say bool has stinger. Yeah, let's give our monster stingers. And let's say bool has hair. Do we want a hairy monster? Why not? And through the magic of copy and paste, we're just going to do a couple of these. So we're going to do that, and then we're going to say I don't know what noise a monster would make. I mean, some gobbledygook, I don't know. That's a monster noise, ladies and gentlemen. That's what that is. All right, so what are we missing here? Has clause and has hair. Oh, yep, because we misspelled this. All right, so now we've got our monster class. You can see this little icon over here, and you can actually see implements method has clause in feline. You can actually click on that, and it'll take you right to the implementation of it. All right, so let's go back to our monster here, and let's go to this chair. Man, my whole little office here is just falling apart. All right, so monster. What do we want to call our monster? Let's call it the Babadook, if you've ever seen that movie. It's kind of a crazy movie. And we're going to make the Babadook speak. And why not? Let's just run this, see what happens. Bang. So there's our lion, and there's our monster making some crazy noise. A lot of work, great, but what has it really bought us? Well, we now have two different extensions of this feline class in lion and in monster, and you can see how we have multiple inheritance going on here. And notice the use of the implements keyword here. That is key. If you try to do extends, that's a different thing. It's kind of hard to really explain, but when you're extending a class, you're extending the class. You're taking it and making it more. When you're implementing it, you're actually implementing it. You're saying, I'm going to follow the directions. So really we're just using, drum roll, you guessed it, interfaces through abstraction. And what has it bought us? Well, we can actually say we don't want our monster to have hair. And when we run, there's no error. Where if we had done this through pure inheritance and we put has hair all the way back up in mammal, because we inherit feline, this whole thing would have just exploded, and it would have said nope, assuming we would have done an assert down here. Whew, that's a lot of talking, but as you can see, you can do some really just crazy, outlandish things. You can make like a airplane that's also a refrigerator, or you can make a car that's also a helicopter. So that's it's a really good example of inheritance, class abstraction, and interfaces. For the source code for this and other tutorials, I encourage you to visit my website, voidrealms.com. Click on tutorials, and drumroll, there is a Void Realms Facebook group with 1,700 other programmers in it. Go ahead and click that link. It takes you right to it, and ask to join.